Welcome to this tutorial on regex in Kotlin. Regular expressions, or regex for short, are one of the most powerful tools for pattern matching in programming. In this video, we'll explore how Kotlin provides excellent support for working with regular expressions, making it easy to search, validate, and manipulate text based on specific patterns. Whether you're validating user input, extracting data, or transforming strings, regex will become an essential part of your Kotlin toolkit. So what exactly is a regular expression? A regular expression is a sequence pattern that helps us search, match, and manipulate text based on specific rules. Think of it as a powerful search tool that goes beyond simple text matching. With regex, you can find all email addresses in a document, validate phone number formats to ensure they're correct, or extract specific data from structured text. Instead of writing complex loops and conditionals, regex lets you express these patterns in a concise and efficient way. In Kotlin, we work with regular expressions using the regex class. There are two main ways to create a regex object. First, you can use the regex constructor directly by writing val pattern equals regex and passing your pattern as a string. For example, regex with \d+ matches one or more digits. Second, you can use the toRegex extension function on any string. Simply write your pattern as a string and call .toRegex on it. Both methods create the same regex object, so you can choose whichever style you prefer. Let's start with basic pattern matching. Suppose we have a string that says hello 123 world. We can create a regex pattern using \d+, which matches one or more digits. To check if our pattern exists anywhere in the text, we use the containsMatchIn function. This function returns true if the pattern is found and false otherwise. In this case, since the text contains the numbers 123, the function returns true. This is useful when you simply want to know whether a pattern exists in your text without needing the actual match. When you need to actually extract the match text, Kotlin provides the find and findAll functions. Let's say we have a string that says price $50, discount $20. Our pattern \d+ matches $signs followed by digits. The find function returns the first match it encounters, which would be $50. If you need all matches, use findAll instead. This returns a sequence of all matches, which you can convert to a list. This is incredibly useful when you need to extract multiple pieces of information from a text, like finding all prices in a document. Regular expressions aren't just for finding text, they're also powerful for replacing it. Imagine you have a string with phone numbers like call 555-1234 or 555-5678. You can create a pattern that matches phone numbers using \d 3 times \d 4 times. The replace first function replaces only the first occurrence with your replacement text, like xxx-xxxx. If you want to replace all occurrences, use the replace function instead. This is perfect for masking sensitive information or standardizing formats across your text. The split function lets you break a string into parts based on a regex pattern. Consider a string like 1, 2, 3, 4, where different delimiters separate the values. Instead of splitting by just one delimiter, you can create a pattern that matches any of them using square brackets, semicolon. When you call split with this pattern, Kotlin returns a list containing 1, 2, 3, and 4 as separate elements. This is much more flexible than the standard string split function, especially when dealing with inconsistent formatting or multiple possible separators. Capture groups are one of the most powerful features of regular expressions. They let you extract specific parts of a match. Let's say you have text like name John, age 30. You can create a pattern with parentheses around the parts you want to capture. The first group captures the name using \w+, and the second group captures the age using \d+. After calling find, you can access these captured groups using group values. The first index is the entire match, and subsequent indices give you each captured group. So group values at index 1 gives you John, and index 2 gives you 30. Kotlin's Regex class supports various options that modify how patterns are matched. The most common is ignore underscore case, which makes your pattern case insensitive. So the pattern hello would match hello, hello, or any other case variation. Another useful option is MULTILINE, which changes how the caret and dollar anchors work, allowing them to match at line boundaries rather than just the start and end of the entire string. You can even combine multiple options by passing a set of regex option values. These options give you fine-grained control over how your patterns behave. Let's look at some common regex patterns you'll use frequently. For matching email addresses, you can use \w+ at sign \w+. For phone numbers in the format of 3 digits, -3 digits, -4 digits, use \d 3 times \d 3 times \d 4 times. To match URLs starting with HTTP or HTTPS, use https:// followed by \w.plus. And for dates in the format year, month, day, use \d 4 times \d 2 times \d 2 times. These patterns form the foundation for most text validation and extraction tasks you'll encounter in real applications.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.